later. Okay. So let's start from where we left off last time. So last time we were talking about two unique kind of situation, right? One is the arrangement, another derangement. So let's start with whatever we were talking about last week and the arrangement problem in itself. There are 5 different people, okay? Say A, B, C, D, and E. A, B, C, D, and E, they have been asked to arrange themselves among each other, okay? And tell me how many different arrangements are there. Now, whenever people are talking about arrangements, one of the things you understand from the last session itself, it also means that there is a numbering, okay? Numbering in the sense, think it like this, that no, this is position number 1, okay? This is position number 2, position number 3, 4, and then 5. So what essentially you're talking about is that in this situation, in this arrangement, A, B, C, D, E, A is in position number 1, B is in 2, C is in 3, D is in 4, and E is in 5. Now this positioning, okay, or is also called ordering, okay, it's ordered. If we change the order, okay, it's not same. So we can also tell now B will occupy position number 1, A is occupying 2, A is occupying position 2, and then C, D, and E maintains their position as in the previous configuration. This ordering, okay, so these two ordering are different, okay. This is all about arrangement. In arrangement, you see that the ordering matters, how you're ordering. However, if I ask you to select if I'm selecting, right, people, selecting means I'm choosing people, right? I'm choose 5 people out of 5, right? It really doesn't matter whether you choose A first, B second, okay, or B first, A second. After all, whatever you choose, that's what it matters, right? It doesn't matter how in order in which you choose, okay, that doesn't matter. So remember, selection is different from arrangement, okay? And this is very, very important because a lot of problem will be looking for arrangement, some problem would be looking for selection. So for good. And then we also took it to something called derangement, right? Where we talk about how many arrangements are there so that the individual elements in the order, they do not go to their actual place, okay? So for example, think of a postman collection, right? Postman means a postman is delivering letters, okay? And I am telling how many ways can the postman deliver the letter in 5 houses numbered 1, 2, 3, 4, and 5, such that none of them receive the letter for which they are meant to be, okay? How many different ways can you do? So for example, a letter which is meant for house number 1 goes to any of the other houses, but not to its own house. And how many ways can you do that? That's a perfect problem for derangement. So we'll again revisit the derangement because it's very important. But before I go there, let's stay on arrangement a little bit longer, okay? And try to see whether you can think of some unique situation or not. If I tell you, okay, how many ways can you arrange the letters A, B, B, C, C, and that's it. A, B, B, C, C. Let's keep it simple. Give me a second. Not like that. A, B, B, C. How many ways can you arrange A, B, B, C? Before that, let's also ask this question. How many ways can you arrange A, B, C, and D? Any answer?
24.
You can arrange A, B, C, and D in 4 ways?
24, Uncle.
24? Okay, yes. How did you get 24?
4 factorial, 4 for the first 3, and then 2, and then 1. Like.
So basically, we're saying that yes, there are 4 positions out there. Okay, in the first position, okay, can be filled by any of these A, B, C, and D can go there. And then you have left with 3 choices for 2, followed by 2 choices for 3, and 1 choices for 4.
Right.
4 times 3 times 2 times 1, which is 24. What is that?
I accidentally added E to the thing, but yeah, it would be 24 ways.
Added means what? What did you add?
I accidentally put A, B, C, D for
Oh, you did.
Yeah, but it's 24.
Okay, no, that's fine. Those happen. Okay. So now the question comes that how many ways can you do the same thing for A, B, B, and C?
Uncle, if we use the same method, like using the position, like the ranking system, the ordering system,
Hmm.
there are three. I mean, you have to exclude 1B because it's the same thing. So there's three possible like letters, right, for the first one.
Only multiple that are like the same order. But
Yeah, there's copies. So we know that it's less than 24.
It should be less than 24. That's a see this intuition is very good, right? That at least okay, we know that okay, whatever the answer, it cannot be 24 because 24 would happen if this first B and second B were distinct, which is not the case here. This
Right.
B like twins, right? Which cannot be distinguished among each other, right? So now the problem begins, right? Okay, how do you handle this scenario when there are okay two two similar or non-distinct, right? Elements out there, which is B and B in this scenario. What we can do is that one of the scene that we do in a scenario like this, okay, is to think or assume that these are different. Okay, so for a moment, think that okay, if it is not same, say I will put like this: B1 and B2, no problem with that, right? Means I know that B1 is equal to B2 equal to B. I know that, but somewhere I'm thinking, okay, what will happen if they're really different? Then it is 4 elements, and the answer is still 24, right?
yeah.
Okay. Now, once it happens, but we know that this B1 and B2, okay, would be creating some unique scenarios. So think of this scenario, right? Whatever I'm talking about. So these 24 scenarios, when you're talking about it, something like this, right? A, B2, B1, C. A, B1, B2, C is of course one of them, but A, C, B1, B2, or maybe B1, A, B2, C. You understand that these are all 24 scenarios. I'm not writing, of course, all the 24 scenarios.
Right. Yeah, I just reordering.
Yes. But then the question is that we see that these two spots, B1 and B2, okay, they are arranging among themselves in many ways, right? Question is, how many ways can they arrange among themselves? How many ways these two, B1 and B2, can arrange among themselves? 2 ways, right? Either it should be B1 is occupying one position, B2 another position, or B2 one position, and B1 means it's nothing but 2 factorial, okay, for a lack of better terminology. So don't you think that okay is contributing to your overcounting factor? So if we divide it by that factorial,
Yeah, don't you divide by 2 factor?
Oh, yeah, if we divide, then yeah.
Yes,
Okay.
because they are ultimately B1 and B2 doesn't make a difference, right? If both are B's, okay, that really doesn't make any difference. So these are the 2 spots, okay, which are when they're arranging among themselves, okay, you are overcounting, and therefore you divide it by 2 factorial to get your
Oh,
answer.
they're doubles, right? So any copy, there's only like one other copy that's like similar to that one
Yes.
other
Yes.
double. So that's when we
Yes.
divide by 2.
Yes. Yes. So let's practice a few more sum, and let's say okay whether we are really able to. I do not want to give you remember any formula, but think of it. Okay, what will happen if I give you this question now? If there are 2 A's, okay, 3 B's, and maybe 2 C's. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, there's 7 elements total. How many ways 2 A's, 3 B's, and 2 C's, which are placed side by side, can arrange among themselves? What is the answer? And do not give me just an answer, just tell me how you're getting the answer. That's the more interesting part. You have got the question, right? A, triple B, and double C.
So typically, we would have 7 factorial possibilities, right, Uncle? If they were all with if they were all different, they're all distinct.
Yeah. So for a moment, we can think these A's, these B's, and C's are all different. Then of course the answer would be 7 factorial, right? Because now 7 times, how many ways can you have? No, 7 elements, then 6 elements. So what essentially you're telling is that instead of A and A, you're telling A1, A2, then B1, B2, B3, and C1, C2, right? This is the way you make them very distinct. So now it's as good as telling there's 7 people, how many ways they can arrange each other. That is 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1, which is nothing but 7 factorial, right? Another way of representing. So far good. But now what do we do? Now the point is that, okay, A1, A2 can arrange among themselves.
Yeah, 2
but
ways.
that does not give you a new configuration, right? Because after all, both are A. right? A1
Uncle,
and
is
A1
it
introduced.
2? Do you divide by 2 factorial
Factorial,
times
correct.
3
Then also B1, B2, they also can arrange
times 3 factorial
by 3 factorial, you divide it. And
time, and then
then
1
you also
do
can do it. So this is also another 2 factorial, right?
right.
All the division, they're overcounting. So now let's do a little bit of calculation. 7 times 6 times 5 times 4 times
Then 2
3
takes
factorial. I'm not
4.
writing the rest
So
of them. And 2
cross out
factorial, 2,
4.
3 factorial, and 2. Happy?
Yeah.
2 factorial is 2 only, right? So 3 factorial and 3 factorial cancels each other. 2 times 2 is 4. 4 also cancels each other. So we have 77 times 6 times 5, which is 4, no, 30 times 7, which is 210. You get the point what I'm doing here?
Right. Yeah, I see.
So
So
this
you
one is
take the total number of possibilities when they are distinct possibilities, and then you overcount, or so you there in the overcounting, so you divide by the doubles created.
that's correct. So let's try to have some terminology so that you can help you understand, okay, what are the overall I'm doing. Before, okay, when you started, okay, this numerator, right? This one is arrangement without repetition. That's what you did, right? There's no repetition here. When you told 7 factorial, you're assuming that there is no repetition, right? And that you made them distinct, and you told arrangement without repetition, right? This is arrangement without repetition. And then you're dividing that wherever the repetition is possible, right? All the repetition cases, okay? Times one repetition, first time repetition case, second repetition cases, okay? You're all multiplying, okay? And that is a denominator, and you get an answer, 210. That's essentially you did. Happy?
Yeah.
Okay. Now I ask a question. I have this word apple, okay? First of all, tell me in the apple, okay, how many ways can you arrange the words of the words of letters in the word apple?
You don't have to make a word, right, Uncle? You can just
No. Any word. I do not care about.
And you just you don't
arrangement. So yeah, you do not care.
Right.
About, I do not care whether it's a real word or not.
Okay.
5 factorial divided by 2 factorial, Uncle.
Yeah.
What is that?
5 factorial divided by 2 factorial.
5 factorial over 2 factorial. Very good.
Because there's 2 doubles and 5.
That's correct. You first assume that as if these 2 p's are without repetition, so you're basically getting P1, P2. So you have 5, then 5 factorial, but this P1 into really not different. So you're dividing with the 2 factorial, the way they can arrange among each other, okay? And you get 5 factorial over 2 factorial. That's correct. Okay. Now the question that I'm asking you is a little bit, think of it, it's not a very complicated question I'm asking. So one of these arrangements, do you agree that would be E, L, P, A?
Yeah, sure.
Okay. So what I've done is that I'm telling you these apples, okay, these 5 factorial over 2 factorial arrangements, whatever you have, okay, I am telling that, okay, all these, okay, arrangements are ranked alphabetically. There'll be all the different arrangements, right? So this, whatever you get, right? 5 times 4 times 3 times, sorry, 2 factorial.
60, right, Uncle?
60.
Mm.
So in these 60 arrangements that you have, I arrange all these different arrangements alphabetical order. So to give an idea, okay, the first one of course would be A followed by E, right? Followed by L, followed by P, followed by P. Do you agree this is the first arrangement that we have if you arrange all of these 60 arrangements alphabetically?
Yeah.
Followed by, okay, again it will be starting with A itself,
then E, then PL,
E,
right?
then P, right? Then we give what's
L,
and then P, right?
Yeah.
And you can continue like that.
PPL,
Yes.
AAP.
So one of them would be PLPA.
Mm.
Okay. So what I'm asking you is that, and this is a little bit complicated question, but if you think, I am pretty sure you'd find a way out. Okay. I'm asking you, okay, if this rank is 1, The first one that you did is rank. We're giving them
Oh,
a
which ranking is
rank.
P?
What is the rank of this guy? Yes, that's the question.
Oh, I've seen these before.
Yeah,
Which
think coolly. Do not think, okay, whatever you have done, okay, just think that what should be the analogy, or how would I do it even? Because
So,
mathematics is all
Uncle,
about.
what I typically do is you find the amount of A I usually, this is pretty bad. It's like laborious,
No,
but I
tell me,
write
go
the
ahead.
amount of the amount of A's there are, and you know that has to be the same amount of possibilities for each letter. So then, but I mean, I'm not sure if I've done this with a doubles question, but I just write out the amount for A, Uncle, then I multiply until I get to the P rank, and then
Let's
I
go a
calculate.
little bit more deeper, right? Dig into the next letter arrangement. So you are basically telling that, okay, fine. Of course, P comes much after A, right? Here in the cycle, okay, P. So
Right.
let's finish the A first, okay? Let's see how many of them are A's, because anyway, I do not care about all A has to finish even before the E comes. Okay, so the first letter is E, followed by first letter would be P, right? So we have to exhaust all the A options, then you have to exhaust all the E options, right? Then only the P comes. Okay. So let's go at least the first letter. Okay, what is the rank of the first letter or first word which begins with the letter P? Isn't it what you are thinking? What is the, first of all, no, you have to first find out, okay, how many are there starting with A? They all are, they are in the rank precedence. I do not need to know what is the order of those words, but at least I need to know how many words are there, so that I know, right, what is the rank of the last one. So then I tell, okay, what are the different words that starts with E, right? Finish that also, exhaust that, okay?
Yeah.
Next one obviously would be L, right? Then I finish
Yeah.
that also. Then comes P, right? Then comes P. Do you agree? So now question is that, can you tell me, okay, how many would be there in this first three lists that you have? Starting with A, E, or L?
Wait, 12?
20. Oh, no, 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 no. 12, Uncle.
What?
12, right?
Should be. Cause like he
Why
switched to
it is 12?
Each letter gets the same. Oh, wait, but Uncle, technically, isn't P double? Like,
he's
So how many would be there? So see, look at this. In all these cases, A is anyway fixed, right? I've told you
Yeah.
that A has to be first. So you do not care about A because you know that A has to be the first. Your now moderation is that how many ways you can arrange ELPP. Think of it.
Yeah.
And how many ways you can do it? If you treat the P's as different, then it would be 4 factorial. But
Yeah.
the P's are actually same. So you divide by 2 factorial.
Yeah.
And that gives 12. Because 4 times 3 times 2 factorial, right? This is 4 factorial means 4 times 3 times 2 factorial, divide by 2 factorial,
and then 4 times
cancel.
2.
So it will be 12. So that means there are 12 cases here, right?
Right.
Yeah.
Same now, if it start with E, okay? Now, rest of the letters, right, will come in some combination, not care about some arrangement. I do not care about this, which would be A, L, P, P, right? Again, the story is same here. So again, how many ways can I arrange? Because E is fixed anyway. So A, L, P, P, again, the same thing, right? 4 factorial divided by 2 factorial, so another 12.
Yeah.
True?
Yeah.
And then we have here also another 12. So 36 definitely gone with everything starting with A, everything starting with E, and everything starting with L. 37th one, okay? What is 37th one? It definitely has to start with P.
Yeah.
Now the question is that, okay, there are a lot of arrangements, right? We're talking about, okay? The 37th is the starting with P, but what do you think would come next? Because P is gone. One of the P's you have taken. What will be next? Next one. A, isn't it?
Yeah.
Then E.
L. Oh, sorry. E.
E. Then
L.
L.
And
Then
P.
P. This is the 37th one, no doubt about it.
You just shift the P, right, to the left, Uncle. You just start with P, but shift everything to the right, right?
because look at this. I have exhausted all letters, all starting with A, E, and
Right,
L.
and you have to alphabetically order it. And P, this is like the first alphabetical combination.
Yes, that's true. That's true. That's correct. Right?
Yeah.
So now we have P, A, E, L, T. What will be the next one?
P A. Wait, no,
Now the
sorry.
question is that, look at
Yeah.
this. You want to exhaust now everything starting with P, A. Do you
Yeah.
agree?
Yeah. So you have to like find all the combinations for the ones after
This-
that.
Yes,
And then
correct. And
keep
how many
going.
ways you can do that? These three?
6.
6. So we have now exhausted all the PS option, right? Do you agree? So another 6 has gone.
Yeah.
37, this was 36. So 36 plus 6, which is 42. So 42 has exhausted all the PA options. I'm sorry, I'm a little bit ugly, but I hope you're able to see it. So all the ELPs are gone. So now
Yeah.
it is gone. PA
PE.
is gone. Now what would be the next one?
PE.
PE. And PE is something we are interested in, but we are a little bit careful now. We don't want to go too fast now.
Oh.
Okay. PE is there. But what will be the next one?
A.
You want to give
A.
the A as precedent, right?
Right.
Yeah.
Followed by
L,
L, followed by
P.
P. Now the question is that PEALP. What is the next one? This is 43.
PE. L.
So first of all, look at this. Of course, this one is an easy one, but in general, what we'll do now, you see that the one that I'm asking you is PEL, right? So that means you have to exhaust definitely now PEA.
Yeah.
So how many are that PA? Of course, there's one more, right? Which is PE,
PL,
LP, and PA, PL.
PL, right.
So basically
Yeah.
2 factorial, which is 2 itself. Right?
Yeah.
Okay. Once this is exhausted, right? Now what will be happening? So we have 36 here, then 6 here, and 2 more here. So 36 plus 6, 42 plus 2, 44. Now 45th one.
PEL, right, Uncle? PEL, now we start.
Now we
Yeah.
have PEL, exactly. PE,
PEL, AP, and then PEL,
PEL,
PA, one
FE,
after.
and PEL, PA, correct.
So 46th. This one.
No, 36 plus 6, 42, 42 plus 2, 44, 45th, and 46, correct. 46. So rank is 46. You see the way I'm going is that first I start with exhaust all our starting one. Then we do exhaust the 2 that is not possible, right? Means not in constraint, okay? And then we move on, and then we go up till this point and get the rank. You see the argument? It's pretty simple argument, okay? But we have to go in layers, right?
Yeah.
Finish all the first, then go to the finish all the seconds, then finish all the triples, okay? Before we arrive, whatever. It could have been a question, could have been a little bit more complicated. But this is the general structure that you do for finding the rank of an alpha, rank of the arrangement. Okay?
Yeah.
Sometimes they give questions on that. That's why I wanted you to understand this. Yeah, I'll give you some problems also so that you can try it out. Let's move on, okay?
Okay.
Next one we have is related to, yeah. Okay. So now let's talk about how many ways can you arrange three people in a circle. So think of it, 3 people are trying to sit in a circular table, okay? Right? But the ranks and there are chairs, okay, which are mapped as 1, 2, and 3. Okay. I'm asking you how many ways can you arrange them, okay, among themselves? 3 people, A, B, and C.
Wait, sorry, what was the question again?
Question is that previously, whatever questions I was asking you, always the assumption was that the people are standing in a line or sitting in a line, right? Line means a straight line. You remember all of them are showing you, I was drawing like this, right? I was telling you they're in a line, right? Single straight line.
Yeah, Uncle, I'm not sure if this is a bad question, but how is
hold on. First of all, let me fragment your bad question thing. Nothing is a bad question, Manu. Okay. In fact, bad questions are the best questions for me. Okay. So Do not tell that this is a bad question. That is the hesitation that you have. Throw the question now.
What would be the difference, Uncle? I'm just assuming because if you put like the ordering, you can also flip it, but I'm not really sure how much changes.
See, whenever you talk about straight line, there is a starting and ending point, right?
Yeah, that's what I was thinking. Like you can, you
Here,
can read
there
it
is
from.
no concept. You cannot tell A is the starting or C is the starting, right? Actually, there is no starting and ending in a circular arrangement.
Yeah, because Uncle, you can choose a point. Like you can't, I mean, unless you choose a point to revolve it around it, there's no like way you could
Yeah. So
really.
let me help you. Okay. So look at it. Okay. If you are one, okay. If you are the person one, okay. If I ask you, okay, where is two? What will you answer?
Repeat your question, Uncle.
Okay. Let me repeat to you. Think of this arrangement where they're in a line. Forget about the circular thing altogether. If this B person is being asked, okay, can you tell me where is A? What did it answer? If the person is asked where is A?
It's before.
Before or to the left. I mean, depending on how left or right, depending on how you see it, okay? But yes, before is a good way of telling, okay? If I ask this here, the same guy, okay, say this is B, and this is A, and this is C. If this B is asked, okay, can you tell me where is A? What will you tell?
I mean, you could either say like after. I think you could either say before or after, based on.
You can tell one before, okay, or tell no, two after, depending on whether you are going clockwise or anti-clockwise.
Who did you ask? B? Where
is A? So
you asked where A is, okay.
So B might tell, hey, if I go anti-clockwise, then I know if I go just one step anti-clockwise, I will find it. Or he might tell, I will go 2 steps clockwise, then I also find it.
Yeah.
But this is possible because it's in a circle. This kind of language or this kind of semantics is not being true in this linear arrangement.
Yeah.
So what we do is that whenever a circular arrangement is there, okay, we have to see, does this arrangement is unique in some manner, okay? So for example, A, B, and C is nothing different from B, C, and A. Ultimately,
depending on where you see it, it's the same thing.
Correct.
Yeah.
So A, B, and C cannot be treated as different from B, C, and A. Because look at this, A, B, and C, okay, A followed by B followed by C. Now it will come to C. If you start with C, then C followed by A followed by B. But this is different from C followed by B followed by A. Can you tell me why? I'm telling A, B, and C is different. C, no way. See, A, B, and C. So it could be A, B, and C followed by or B, C, and A or
C, A, B.
A and B. Right?
So it's like a different ordering, almost like a different
order means no, it's clockwise, anti-clockwise is changing, right? So you have to go tell A, B, and C same as B, C followed by A or C, A followed by B. But it is not same as C, B, and A.
But it's based on the direction, Uncle, right?
It's based on direction. It's based on direction.
To go counterclockwise.
It's counterclockwise, correct. So now this arrangement is different, right? If I tell you, right? So see, see, C, B, and A would not happen. C, B, and A, when I'm talking about, you're going like this. You cannot make a C, B, and A by going clockwise direction. But A, B, and C, B, C, and A, and C, A, and B, they have a clockwise notation, okay? As far as whatever I've shown you.
So would the question want us to go clockwise or counterclockwise?
Question is asking how many ways you can arrange. So I'm telling you is that here the concept of arrangement depends on, okay, whether by rotating the table, okay, will it leads to the same configuration or not. So think of it, you are in a circular table, okay?
But Uncle, aren't there just two? Uncle, in
answer is two. Answer is two. You're right.
There are two,
the
right?
answer in this scenario is two, okay? But
there are two configurations.
Yes, there are two configurations only. But what will happen? Let's make the question complicated. But Srinita, by the way, do you understand why it is two?
Is it because there's only two directions you can go for the arrangements?
No, not that. Here, so that was very simple because I gave you three. Okay, let's think of
There's
another
like two
problem.
configurations.
Yeah, configuration. So think of it this question. Now we'll, I think you will get the answer, Srinita. Okay, if I tell A, B, C, and D, okay, how many ways A, B, and C and D can arrange among 4 chairs, okay, which is 1, 2, 3, and 4, okay? What is the answer in this scenario?
24.
Is it 6,
You think
Uncle?
24? It must be less than 24 because I
Is it
told you
6, Uncle?
that the clockwise connotation would be no same. So I'm telling that A, B, C, D is same as B, C, D, A. Is same
Yeah.
as
Or C, or is
D,
it
D,
the
A,
same
B.
as C, D, A,
Same
B?
as D, A, B, C.
Wait, Uncle, is the
But remember,
answer
in a circle, in the linear, okay, all these are different. I wanted you to understand these are all different in a linear arrangement. So there, the 24 answer was correct because no, these are different arrangement. But in this circular notation, okay, A, B, C, D is same as B, C, D for return back to A, or it could be C, D, A, B, right? Or it could be D followed by A, followed by B, followed by C. You see that? So the question is that no, here you cannot, it cannot be 24. It must be less than 24.
Yeah. So
Uncle, can I just check if my answer is correct to make sure my logic's right?
Yeah, go ahead.
Is it 6, Uncle?
Answer is correct.
Okay. Then I think I understood the
how'd
concept.
you get it?
Do you want me to explain, Uncle?
Yeah. Go ahead.
Okay, so what I think this is like the general formula for a question of this like caliber. It's you take the amount of it's a fractional thing. So on the numerator, you put the amount of total, like you think of it linear, like you know how like linear you just do 4
Yeah,
factorial,
you
which
put
is
the
24
linear thing on top. Yeah.
arrangements, right? Like, like that's typical, right? So there's
Yeah.
24, and then on the denominator, however, you divide by the amount, like the number of digits.
So 4.
Because, yeah, there's it's not like that's not like the exact, I don't think it's exactly digits, but there's 4 different configurations.
Like 4 positions.
Sort of,
Right.
yeah.
Yeah.
If there are n people, then what is the idea? So there are, say, A, B, C, D is 4, right? If there are n different people and they are in a circular arrangement, okay, how many ways they can arrange among themselves?
N factorial.
Mm.
N factorial. Then it cannot be n factorial, right? N factorial was correct. If they're
Linear
linear
or
arrangement, but now
circular?
we have a circular arrangement.
Oh, okay, then divided by n.
Divided by n, which is nothing but n times n minus 1
minus
factorial
1.
over n. So n, that means n minus 1 factorial.
Right.
Right? So it looks like it is n minus 1 factorial, and in fact it is correct, but I do not like the logic. The way you told it, it looks like you have seen the formula, or somehow, or just by a pattern. Okay, the way
Yeah, I think it's by pattern, Uncle.
pattern. And see, pattern is a good one, but as a mathematician, I do not like pattern fully. I mean, I like it. I'm not telling I do not myself use it, but pattern is only the step number 1. Okay, that looks the pattern. Okay, but pattern sometimes can belie your expectation, right? So we have to have a better logic. Okay, and I give the logic. Okay, if this circular arrangement is a problem, okay, think of it. Okay, this guy, okay, this chair, okay, there is a picture behind the in the wall. In other words, I'm thinking that, okay, this A has been fixed to the chair, right? A has been fixed to a chair, okay, and the chair has a picture behind it. So think of it, this is not completely fixed. If A is fixed, okay, then how many ways can the rest of the people arrange around it? Either no, they would be left, right, or like that, right? A is fixed. A is
3 factorial.
huh?
3 factorial ways,
3
Uncle.
factorial. And that's exactly correct, right? Because once A's position is fixed, if you arrange among
Oh,
them,
and then
right?
you can do it for like B, you can fix B or C or D, right, Uncle?
I'm telling fix any one of them, okay?
Right.
Because if you fix one of them, then don't you think that this problem becomes a linear problem altogether?
Yeah.
But now the question is as good as telling A is fixed, but B, C, and D are arranging among themselves.
And either, like, it doesn't really matter which one's fixed because it's going to be the same anyways.
That's correct. Any of them can be fixed. So the point is that so as good as telling a circular arrangement is nothing but make one of them fixed, okay, and rest of the people let them arrange among themselves in a linear way. Then it becomes
otherwise it's going to be the same.
Then it will be n minus 1 factorial, right? So if you have n people, one of them is fixed, okay, whoever, I do not care who is fixed, okay, to make one of them fixed in the chair and let the other people know the left and right, the clockwise and anti-clockwise people, let them arrange. So that becomes a line. So in another way, you can also think of it. If you think of a circle, okay, anything in a circle, if you cut the rope, what will happen? It will become a line. Do you agree? See, circle's problem is that how did you start the circle's problem? It has no starting and end or an end, right? Circle does not have a start or an end. But if the circle can be cut, okay, then it has a circle end. So I'm telling wherever A is sitting, think of it, that's the position I'm cutting it. The fixed position, okay, I'm cutting it. Then I'm left with n minus 1 people, right? These are the n minus 1 people. And they are now arranging among themselves.
In n minus 1 factorial.
1 factorial ways. That's the answer you told me.
Right.
So that means, again, n minus 1 factorial is the way of arranging, okay, among themselves.
Okay.
Right? Okay. However, this question becomes a little bit more complicated. Instead of people, I give you necklace beads, okay? Have you seen necklace beads, okay? There we have small beads there and we make necklace with them.
Yeah.
Now, if there are, say, 5 colors, 1, 2, and say red, okay, blue, okay, green, yellow. Of course, I have never seen a necklace like this, okay, but who knows what it could be. And then maybe
Purple.
Okay. So I have 5 colors, okay. I ask you, okay, how many different kind of necklace can you make, okay? Different arrangements of beads with different arrangement of beads. How many necklace can you make, okay? How many arrangements can these beads do among themselves and produce different variations of a necklace?
Well, one time you mentioned that beads are different than humans, right? They're
That's true. That's a bit
because they're like,
why beads are different than human beings?
Human being, you can't like flip them upside. They have one configuration on their own, but beads can.
That's correct. That's correct. See, in this example that I'm telling you, right? A, B, C, D, okay? If I'd flipped them, if the humans could have been flipped with the legs on the ceiling, okay, and the heads towards the floor, okay, how would it look like? I mean, you standing on the floor, how would it look like? Think of it. A, B, C, the table has been uplifted and the legs are all on the ceiling, okay? How would this arrangement look like? Don't you think the clockwise would now become anti-clockwise?
Yeah.
A, B, C, D would now become A, D, C, B.
Yeah.
But nobody that arrangement is not a feasible arrangement, right, with a human being. So that's why it makes sense that clockwise and anti-clockwise, these two, you treat them differently. But in beads, okay, that's not even a problem. You can flip a bead, right? That means there the answer would be a little bit different. There it would be n minus 1 factorial divided by 2. And where did the 2 come from? It could be clockwise, anti-clockwise, the overcounting, right? You divide it by 2.
Yeah.
You get the point?
Oh, that was my reasoning for the other one.
Which one?
The one before you asked what.
Human being.
So the configuration would be 2, but
yeah. So that extra 2 is nothing to do with your arrangement. It is more to do with the configuration. That okay, here the clockwise and anti-clockwise pattern loses its significance for the simple reason it can be flipped. But human beings cannot be flipped like that. Human beings can be arranged, but they cannot be flipped because we cannot have our legs on the ceiling, right? Therefore, it loses its meaning. So we are now seeing 3 kinds of patterns developing so far. If they're all in a line, n people are in a line, and all of them are distinguishable or distinct, then there are n factorial ways of arranging among themselves. We saw that, right, in line. If these n people, okay, who cannot be flipped, of course, right, they are put in a circle, okay, and they're all different people, then it could be n minus 1 factorial over 2. Sorry, n minus 1 factorial, okay, of arranging themselves. If it is something that can be flipped like a bead or maybe something else, okay, which does not have this concept of a head and a leg, or no head and a tail, right? So if they can be flipped, okay, and does not change essentially anything, okay, that means that it loses the significance of clockwise and anti-clockwise, and therefore you have to divide by 2 to prevent that overcounting effect, which is n minus 1 factorial over 2.
Yeah.
So keep this in your head, because whenever the question comes, ask yourself, is it the question of a human beings? Is it a question of people sitting in a circular table like thing, or is it a necklace where the beads, and which can be flipped? Okay.
Or human beings, would the same apply for animals? N-1 factorial?
It depends. I think the question will be amply clear. Okay, that can be done. They will not make you know what I should tell. It's not a puzzle, right? Where there's a trick in it. Okay, mathematics is not about trick. Okay, so they'll make it amply clear. Okay, whether it can be flipped or not.
All right.
In fact, even if you see a necklace, okay, they would tell you that okay, it can be flipped, and the flipping effect will have no difference in the arrangement. They will make that line amply clear in the question itself, so that you do not have a no that, oh, should I go for it, or should I divide it by 2 or not divide by 2? Okay, that
Yeah.
there will be some hint in the question itself which will tell you that okay, should you go for it or not go for it. But are you clear with these 3 different unique arrangement that you have?
Yeah.
Yeah.
Good. Now let's move on. So now what I'm asking is, I start from a position, one particular position which I'm calling as A, okay, and I'm telling, and there is another city, okay, called B, and then we have a third city as C. Okay, I can go from city A to city B in 5 ways. There are 5 roads. 5 ways means 5 roads, and from city B to city C in 4 ways. So I'm telling 5 ways means there are like this, right?
Yeah.
And there are 4 ways means 2, 3.
This looks like mitosis.
What is that?
This looks like mitosis.
Okay. Mitosis. Okay. And then there is also, okay, 2 ways of going directly from A to C.
It looks like GPS too.
Happy?
Yeah.
And then there are 3 ways going from city C to city D.
Thanks.
Okay. I think this is enough for you. I'm asking you, how many different ways can you go from A to D?
Oh no.
First, you can give me an answer, but I would still ask you to explain. Okay. So tell me, first of all, what's the answer, if you have one?
Would it be
Think and tell. I do not want an immediate answer. Think of it, have a good logic for it, or why you are telling whatever you are telling. I want an accurate answer rather than
so I was thinking, like, I'm pretty sure in some way you have to get from A to C first in order
Is
to
it
get.
66, Uncle?
Whoa, I was not thinking of it.
What is that?
Is it 66?
Yes, it is 66.
Okay.
How do you do it?
I mean, so you have the 2 ways on the outside and then 3 ways to get to D. So that's like a separate possibility on its own. And then the A, B, C, D possibility is like its own separate possibility, like its own link. So for the A to D using the 2 direct ways, or like the direct ways to C, there basically it's not really a problem of like, first you have to find out how many ways it is to get to C, and then you so okay, basically A to C, using the ACD path, you get there's 6 ways to get to D. 2 times 3, there's 2 ways to get to C, and then from C to D it's 3 ways, so 6 possibilities there. And then from the ABCD path is 5 times 4 times 3, so 60 ways. Therefore, you add both of the possibilities, and then you get 66 possibilities.
Yeah, I think you are correct. Okay, so let me break it. Okay, how we can think, and this network, okay, solving this kind of network is one of the foundational steps in whatever you'll be doing in probability, okay? So moment you are becoming very good in this, and when I'm this, okay, I'll tell you something. This is nothing to do with a combination or combinatorics problem, okay? This problem is all about addition and multiplication. I'll tell you in a minute, okay? This we have been always doing without knowing what we are doing. First of all, before I go there, I ask you something which you all know, right? If I ask you 23 times 36, how do you do it? Don't tell me that, okay, fine, somebody, your teacher has asked you how to do a multiplication. You have to tell me what's the right way of doing things if this question was asked. Don't tell that, oh, I know how to do multiplication.
It's
2 times 3 times, or 20 times 36
Yeah.
and 3 times 36, and then you add the 2.
Okay. So 20 times 36 could be a problem for somebody, right? If they do not know, then I think one of the best ways to do it is this.
So, oh, you make like 4, like there's 20 times 30.
Correct. You have got it. I understand. You have got it correct. So we can tell 20 plus 3 makes 23, right?
Right,
And
Uncle, I
Yeah.
think you showed me this to like how we would explain to Aishani, right?
to Ishani, exactly.
Ishani,
Yeah. So yes, so that's the kind of a repetition. I keep on telling this so that it gets into your head, okay? But you have got it correct, okay? So what essentially I'm telling 20 and 30 here. So 20 times 30 is 600, okay? And then 30 times 3. So 30 times 3, because this is 30 also, right? So 30 times 3 is 90, right? Then you're telling 6 times 20, which is 120, and 6 times 3, which is 18. And then you add all of them, right? Basically, you are first of all adding the rows first, or maybe the columns first, depending on how you want to go. So you're telling 600 plus 90, which is 690 here. And we have 120 plus 18, which is 138. And then you add these two together to get the final answer. Do you agree?
Yeah.
Now, this is what we would be doing in probability again and again. I keep on telling because I have seen one of the guys, Oxford University, do you know?
Yeah.
Yeah.
So she was not my student, okay, but somebody from a common friend, okay. She wanted to know before she took an admission last year, and she got a chance in Oxford University, okay, one of my acquaintance, okay. So she was struggling before going there in economics, of course. She was taking in Oxford, okay. She's studying now in undergraduate. So she approached me for some few problem because she was struggling with the probability last year, maybe, or year before that, yeah, maybe. And then I saw that all the problems that she was struggling because and she was a good student, you understand, because somebody is getting into Oxford is not a thing, and they have a very strict admission test there, okay. But I found that, okay, she was good in mathematics, but she was struggling with this concept. I'm telling you why. So look at the problem that I'm showing you now, okay. Here you did exactly that. You are telling A to B, how many ways can you go? 5 ways directly, right? If
Yeah.
A to B and B to C is 4 ways, then for every way of going from A to B, okay, you have 4 ways of going to B to C. For every way of going to A to B. So look at this. For example, if I write this, okay, as this first path as A, B, okay, not A, B, let me put it like this. Say X1, X2, yeah. X3, X4, X5.
Not think that.
You've got it, right? And this one is Y1, Y2, Y3, Y4. So we can have X1, Y1, or you can have X1, Y2, X1, Y3, and X1, Y4. Okay.
Each time.
And each time you have similarly X2, Y1, X2, Y2, and you continue like that. So you understand there are 5 times 4 ways. That's essentially how we can go from A to C.
But wouldn't it then also be 100? Because
hold on. Do you agree up till that A to C with only these paths, okay, we can go in 20 ways from A to C? Okay.
Yeah.
And then also we can go directly from A to C in 2 ways, right? Through this path. Do you agree?
Yeah.
So then we have 20 this way, and then directly from A to C another 2. So we have 22 ways of going from A to C. Do you agree with this particular thing? So,
yeah.
So this is 22. So there are 22 ways going A to C. Now look at it. For every 22 ways of reaching C, okay, you have 3 ways of going from C to D. So if after this 22, you're telling, hey, this whatever 22 ways you have, right? Each of them can be, can be go through this path, this path, or this path. That means 22 times 3, multiply.
Yeah, 22
And
plus
that gives you
22 plus
66, which
22.
is what Manu told, right?
Okay.
So what do you do essentially? Didn't you use your idea of multiplication and addition? I did not talk about anything else, right?
Yeah.
What do you do here? Same thing. You did multiplication and then you added them.
Wow.
You are multiplying and adding them, right? You are basically telling that, okay, now look at this. If I told you forget about 5, okay? If I tell you there is X ways, okay? X ways of going from A to B, not 5 ways, okay? Y ways of going from B to C, Z ways of going from A to C, and say W ways of going from C to D. What would be your answer? Your answer is very simple. It is X ways of going A to B. For every way of going from A to B, you have Y ways of going from B to C. So their total X times Y ways of going from A to C using this circuit, okay, this portion.
Yeah.
And then you are telling, hey, but these Z ways, they're independent, right? They do not go through B, okay, they can directly go from C. So let's add that. Isn't it? Z ways of going from A to C directly. Do you agree or not? It's
Yeah.
confusing. You can stop me. And then, well, now we have reached C, right? Now we have so many ways of reaching C, X times Y plus Z. Now I'm telling for each of these X, Y plus Z, okay, or ways of reaching C, we have W ways, this W ways of going from C to D. So multiply that with W. So your answer is X, Y plus Z, whole thing multiplied by W.
Yeah. That makes so much sense now.
That's looks like a not a kindergarten, but no first grader or second grading, because after all you did not know variable that time, but you knew what is the concept of multiplication and what is the concept of addition, and that's exactly what we did. So ultimately, Srinita, means, for example, if you try with your sister, okay, with a small thing, okay, you'd be surprised that she might also understand. Maybe I'm not telling always I think, but I've seen sometimes even kids know, if you explain them, okay, they are able to understand what you're talking about, okay, because it is very, very easy, right? Our human mind, okay, we know multiplication, addition, okay, but this is not a complicated question. We are making it more complicated by overthinking, but ultimately it's a very easy question that we are being asked.
Yeah.
This question can also be attempted in another way. Okay, you can think of it, what are the independent? Look at this. Can you reach, if I think of all these different paths, okay, can you reach here A to C without going through B? Answer is no. At least in this zone, right? Whatever paths we have, everybody is going to B. That means B, A to C is dependent upon how many times, how many ways you can reach B. Okay, that would drive, okay, how many ways you can reach C. But these two paths, not two, the Z ways, okay, these paths, they do not have any dependency on B. They're independent of how many ways you can go to B. Moment it is independent, you are using the add operator. You see that?
Yeah.
Okay. Again, look at this. Once you reach C, okay, how many ways you can reach D, okay, that depends on how many ways you can reach C. That means there is a multiplication effect, right? And that's why the whole thing is multiplied with W. That means if there is a dependency effect, dependency means if you're dependent, okay, on the previous thing, then there is a multiplication. If it's not dependent, okay, then you have additive effect. That's true, because multiplication, okay, multiplication depends on the product or the multiplicand, okay, and the multiplier, right? Addition, on the other hand, is not like that. Addition is very, very independent. Okay, those two terms are independent. They have no connection. When you tell 2 plus 3, they do not have connection. When you tell 2 times 3, that is nothing but 2 plus 2 plus 2, right? So you have some kind of dependence, okay? Get into your head when a problem beings come, okay, instead of right now using some formula, okay, ask yourself, is it a dependent problem or is it an independent problem? If you can ask yourself this question again and again, okay, you'll become stronger in any kind of probability question, any kind of counting question, including combinatorics. Students struggle in combinatorics historically. I'm not telling now, okay. I have seen even in because I do some of this machine learning thing, okay, where you need a lot of combinatorics idea. I think people are not able to understand. I've seen because of the only one reason. They overthink. They do not think, okay, it's nothing but a multiplication and addition problem. I do not want you to overthink. Keep it simple. Think of it, okay, is it additive effect or multiplicative effect? Moment you have an answer, you see that you can solve the problem easily.
Uncle, can you explain the dependent or independent
Okay,
question?
I can tell you. If you have to go from A to C, okay, in this zone, the one that I'm circling right here, can you reach A to C without going through B? Can you reach from A to C in this only this zone, not these two independent paths?
No.
So B becomes a dependency. You have to pass through B to reach C. There is no other way. Right? So if you have to reach through B, okay, B becomes a kind of no problem for you. So you have to first.
Basically, getting from A to C is depending on whether you get to A to B.
Correct. Absolutely. So that means A to B, okay, has a dependency on telling, okay, how many ways you can go from A to C. But that is not true when you are talking of A to C directly. They're independent. So anywhere when you do not have this dependency, right, and do not have the dependency, which is no this case and the independent cases, right, where directly going from A to C, these two are independent phenomena. On the other hand, when you're going through B, that's a dependent phenomena, because depending on how you go from A to B, that will drive how many ways you can go from A to C, because you cannot go to A to C without with bypassing B.
Okay.
So, okay, so that dependency, okay, is what would drive not so much about combinatorics, but what when it comes to probability, this simple topology, okay, we call it topology, okay, you'll hear this word, okay, if you're in maths, okay, people know, but this is a more of a geography word from geography, the topology, right? Topology means how the contours look like, okay. Do you know contour, or it's not been taught? No, you know what is contour? Anyone?
It's like the thing for like elevation.
Correct, absolutely. So it's
Yeah.
correct. It's good to know from science, or no, it's very important. So you have this, no, you have hills, right? Like the way I drew here. Okay. So if you really, this one is two-dimensional picture I drew, right? But if I want to show in three-dimensional, how would it look like? For example, look at this. This elevation might be looking, no, around this, okay, around this hill, okay, in a certain way. So what we
Like
do
a
is that,
cone, right, Uncle?
yeah, we can draw like, yeah, it's correct. This is the peak, okay? So we can tell, hey, this is how, you know, topology. So this guy, okay, this guy is this topology, so right? So I'm drawing this, you see that? This is, so I'm telling you how the surface looks like. There's another peak here. I will draw here, okay? Another peak.
Right.
And this is the valley, right? This gap is the valley. And then you have another valley here, okay? There's this another topology. Now, topology is, though it's a geography, but a mathematician also has something called topology. And we study this, okay? A heat map also, it depends on that. Heat map means how is the body heat, or no, heat map also tells the data distribution, okay? Very interesting thing. So it has a lot of work in topology, okay? The topology is a branch of science where you deal it, and now those people who would be going for calculus, okay? And later on, if some people go for machine learning also, so they would also be learning a lot, because this topology drives the entire, you know, calculus. If you do not understand topology, okay, how things are gradient, okay, how it changes, okay, you will not be able to grasp anything in calculus. Calculus would be a very little boring subject, but those who understand gradient, and I'll be talking about it as we go along, but try to understand what topology. When people talk of topology, is mean how the data changes, right? So here, for example, by looking at the diagram, you know, okay, how is the distribution of the elevation, right? I think Srinita told elevation, correct way, right? That how is the elevation changing, okay, as we are moving along, right? You can tell that by looking at the diagram. So that's called topology. Now, I was talking about topology here because this is also topology, because it tells you how you can reach from A to C, right? Through different maps. And that's a kind of topology. Got it? Okay, without talking much, I think we are spending too long a time. Okay, let's move along. And any questions so far? Good?
Yeah.
Yeah.
Okay, so let's go to the next one. Important thing. So I ask you now, Somebody starts walking from A, okay, and moves along this route, okay, whatever I'm showing by arrow. Okay. Can you tell me how many ways he can reach from A to B? But they can move along only along the paths that I've told.
So only like
Only
right.
X is one of the halting point, because you ultimately this is not, this looks so fancy, but ultimately this is not a halting point. So he can go from along this route, right?
All I can say right now, like based on like the dependent thing, you need to, in order to get from A to B, you need to pass
Just
X.
4, right, Uncle?
4, because
4.
this is pretty simple, right, Srinita? Do
Yeah,
you
you have
4?
one way to go to X,
A to
or
X, A to X is two ways, right? Either you this one
yeah,
or this one.
yeah, 2 ways to go to X and 2 ways to go to B.
2
So
ways.
4.
So 2 times 2, because you are dependent, right, on X. So 2 times 2, with multiplicative effect, okay, and then the answer is 4.
Yeah.
This is pretty simple. But now let's change this question, okay? And I'll ask a lot of questions, okay? So stay with me. This is something I know Srinita has seen and Manu has also seen last time, but I again want to refresh, because I see that most of the questions where people, students that I have been interacting with, they struggle, okay, because of one single deficiency is that they do never, then they're not able to encode. I'll talk about this word encode in a minute, okay, and you will understand why it's so important. So look at this. A to B, okay, and these are all halting points, okay. However, you're allowed to move only along left and to the top. This is something Manu I covered in the Zoom class, okay. Srinita was not there, okay, but just to refresh that you have really understood it, okay. I want you to tell me, okay, in this particular scenario, why do we have how many columns? Or how many rows? 2 rows. And how many columns? 1, 2, 3, 4, right? 4 columns. So 4 columns and 2 rows, right? How many ways can you go from A to B if you are only allowed to move towards right, okay, or you're allowed to move up? So you're not allowed to move bottom. So if you reach here, for example, this one that I'm highlighting, you're not allowed to go bottom. You can only go up or go to the right. So how many ways can you go from A to B? And you
Uncle,
can go from one lattice
do this
point to
as
another lattice point.
yeah, you did like sticks, right, Uncle? Like or like 4 or 5.
No,
Or
I don't want to memorize. Okay, this memorization you have to stop. So you can think of it as a new question being thrown at you. Think about it and give me an answer. I give you 1 minute exactly to both of you. Srinita is slightly disadvantageous position because he did not join the Zoom. But it's not such a difficult question I'm asking you. What's the answer?
Uncle, there's only 4 ways to go right and 2 ways to go up, no matter where you go, right? So
That's correct.
I so far I know that like wherever like which square you go on to, you have like 2 sides that you could travel along. So
2 sides in the, what do you mean side? We're talking about two kinds of movement, right? Up movement or right movement?
yeah, of each like square.
Okay.
Because you
So
can't go left or down.
Uncle, is it 15?
how did you get 15?
So there's 2 rights and 4 ups, meaning that there's 6 moves no matter what.
Yeah.
Like any
Not 2 rights, you're
Poss-
taking 4 rights, right? You mean 4 right?
or 4 rights, 2 ups, sorry.
Correct. 4
But
rights.
no matter what, you have 6 moves to get to B because you can't go left anyway, so 4 rights and 2 ups. So it's I did I mean it doesn't even matter, I'm pretty sure, but I just did like 6 choose 4
Or 6 choose 2, because
or
6
6
choose
choose
4.
2 because
Yeah,
choosing
6 choose 4 is same as 6 choose 2.
choose
Why?
2.
Why
Choosing
is
is also the same as not choosing.
Yes, correct. So choosing is not same as not choosing. So that way, either way you go, you will get the 15 only. Because 6
Yeah,
choose
first
2 is nothing
because
but
even
6
if you
times.
choose Uncle, you either choose the first 4, like the 4
Yes,
rights or the
yes.
4 or the 2
So let
ups.
me, yeah,
Doesn't
let me explain that. Yeah, absolutely correct. Okay. So look at it. Okay. Wherever you go, right? Ultimately, you would end up. So, for example, if I take this path, the one that I'm putting it in bold for you to see. So here, how many are going right? This one is first one is right. Okay. Second one is right. So this is right R1.
2 rights.
Right 1, right 2. Okay. Then up 1, right 3. Right. Then up 2 and right 4. Right. So how many rights you have gone? Rights is means R1, R2, R3. But R1, R2, R3 are that not this indistinguishable, right? They are sorry, they're not distinguishable, they're indistinguishable. They cannot be made distinct. So we can tell this particular arrangement, okay, I can put it like this. I tell, hey, it is right, and look at this how I'm drawing, okay? Right, right, up, right, up, right. Okay, this is how I'm drawing. Let's take another one. Okay, say going like this, this, and then I'm going completely right. This one, top. So first one up is this, right?
When you go, you have to have 4 rights and 2 ups.
Yes, for whatever you do, you have to go 4 rights and 2 ups. That's correct, right? So that means, can I tell that the number of ways is that how many ways can I arrange? Okay, not arrange. How many ways can I select? Okay,
The 4 rights
4
and 2
people
ups.
out of 6 people, right?
Yeah.
Because 4 people would be, but say the rights ones. Or you can tell another way of telling how many ways can you select the 2 up people, okay, from the 6 people. Because if you have the up people, okay, then you already the rest of them would be right people. You know that the rest of them has to be right.
Yeah.
So that's why I told you either 6 choose 4 or 6 choose 2, because after all they are same. We know that 6 choose 4 is same as 6 choose 2. Because 4 plus 2 is equal to 6, right? Choosing 4 people out of 6 people is same as telling not choosing 2 people out of 6 people, right? And not choosing is also choosing, right? So that these are same thing only. So this will nothing but 6 choose 2 means how many ways can you choose the first people? 6 ways. How many ways can you choose the next one? By 5 people, because the first one has been chosen now. So 6 times 5. But here's the problem, right? Choosing A first followed by B is same as choosing B first followed by A, because choosing is nothing to do with arrangement, right? So we are overcounting here, divided by 2, which is 15.
That makes more sense.
Makes sense, right? Okay.
Yeah.
Now I ask you the next question, and hear me out, okay? Let's see what you do now. So 4 here, right? 4 columns, 2 rows, and here you have 5, 1, 2, 1, 2, 3, 4, 5, 6, sorry, 6, another 6, 1, 2, 3, 6, yes, 6. So I'm asking you, starting from the left corner to the bottom up corner, okay, which is B, and there is a position X, and all these are lattice points. Lattice points means you have to go through them, right? And you're only allowed to again go to the right or go to the up. How many ways can you go from A to B? Now what is your answer? How many ways can you go from A to B? Remember, I talked about some multiplicative principle, right?
You have to do the same thing you did with like the first one where you choose 4 out of
But yeah,
6
the first
to get
one
the
you
math,
know, first
and
one
then you
you
have to
know.
multiply that by the x to the b thing because
Yeah,
it's
yeah.
dependent on whether you get, so getting to a to b is depending on whether you can get to a to x.
Good job. Very good job. So can you come up with an, I mean, not answer, but if you can tell me in time, in terms of choose, it's okay with me. And not give me the exact answer, because that would be
Yeah, I
very.
give
So I
exactly.
know how to get from A. I know how to get from A to X, but from X to B, you can't do the same.
You can, right?
Oh wait, oh wait, yeah, wait. Actually, uh, yeah, you can.
can.
I didn't.
Yeah, exactly. See, I'll tell you what is the confusion running in your brain, okay? Because
Oh, I realize, Uncle. No, it's
tell me,
not
what is the confusion going in your
exclusive.
brain? Means
Yeah.
what is the overthinking part that you're doing? I'll tell you the overthinking what goes in our brain when you see this kind of question. One of the overthinking that goes in the student's brain is that they know very well how to do a to x, okay, if they know whatever we talked about, no, just before this, okay. Their problem begins by doing x. They now keep on thinking, okay, fine, I have reached x, okay, and then I know how to go from x to b. But the problem is that x, no, it's not, we are not using x, right? X is the intermediary thing, right? We are not starting from x, we're starting from a only, right? So they think, how do we connect the dots? Okay, connect the dots is not even important. If this portion of the question was not given to you, how many ways can you go from x to b?
12 choose 6.
12
12 choose 6.
12 choose 6. How
You
many ways
just multiply, right? Inevitably.
you have to multiply? Because again, ask yourself, is it a dependent or independent question?
No, Uncle, I thought it was 6 choose 6, and I was like, that's only one. But then I realized you add the both.
And you're dead, right? That's what you did,
Right.
okay?
That's all I had to remember. But otherwise, yeah, I know how
Yes.
to spell.
And here it is 6 choose 2, right? Or 6 choose.
So 15 times 9, 24.
You get this point, right? See, I want you to understand each and everything here. Do not take it as a formula, okay? Where did you get this? Where did you get this? Why are you multiplying? If these three questions, if you have no complete clarity, okay, then the question is done. Then I think most problems, whatever is being thrown at you, will be able to do. If you do not understand any one of these things, you have a problem in hand. Don't assume things, don't think, don't do things whatever I'm asking you to do, because that would not help you. Think, okay, why are you doing? Clear?
Yeah.
Can I move on?
Yeah, sure.
Okay. Okay. Do you know what is greatest common divisor? GCD.
Yeah, Uncle. Yeah, I do. An LCM, right, Uncle? GCD.
Yeah. But I'm not interested in LCM right now. Interest is on GCD. Yes, GCD and LCM are inverse kind of operations functions. Okay. But what is it?
Uh, um,
What
it's like
what is the full form of GCD?
the greatest common divisor of two integers, like two, like the, or even more, like just two or
By
more.
the way, does GCD also can be done for fraction?
I think so. Yeah, Uncle. You can.
You can. And what is
Yeah.
the greatest common divisor of a factor of a fraction a comma b and c comma d? How did you?
ACVD.
Huh?
ACO. Greatest common divisor.
Of two fractions, a divided by b, a over b, and c over d. Okay, if I ask you to find the greatest common divisor of these two fractions, how do you do that?
BD is definitely on the denominator because you have to have like the.
So we have, no, I do not think, again.
Wait. Actually,
Can
I'm not
let's
sure.
stop it. Okay, I do not want to. Yeah, that's fine. Not sure is actually a good answer. Okay, not do not, I know it, but I do not know fully. See, greatest common divisor is another area. Now we are entering into the thing, and I'll now bring the combinatorics and why GCD I'm talking about are so important. Okay, these are fundamental thing. And when did you learn GCD? I think maybe 6th grade or 7th grade. Not know when they teach here, school, but or you may have learned it before also. But when did you learn GCD?
4th grade, uncle,
4th
maybe.
grade. Yeah, that's generally they should do in 4th grade. Yeah.
But they never taught with fractions, uncle, mostly just
No,
numerical.
fractions, forget about you. Even we are not being taught. Okay. When I was in school, okay, I never, throughout my school, nobody taught me what is fraction. Okay. But we keep, when you're in school, okay, these things come and sometimes you go a little bit top of the school, right? And you try to understand. But the point is that not that no, whether you can define or not. These are human beings, we have made it, right? This greatest common divisor, etc. Okay, that's operation, right? But again, that's not important for me, whether you can do it for fraction or not do it for fraction. Question is that can we use the concept of GCD on a fraction or on an integer to solve a problem, right? Then it becomes interesting. Okay, how you define, see, I tell the sum operator as plus, or do I tell it, okay, as something else? Okay, something like this, okay, number as plus, okay, real doesn't matter. Incidentally, this is called product, okay, this is called sum, right? But ultimately understand, essential thing is that this is sum of, okay, two things, right? Similarly, this is product of two things, right? A and B. So the function is important, right? What it does is important. How you define it is not important. So GCD is a definition. It's a function. Just like sum is a function, right? Just like choose is a function. Choose means I'm telling 2 choose 3, right? This is a fancy way of writing. Ultimately, you're telling, hey, you have to choose, okay, m things out of n things, right? Or n things out of m things. This is important for me. Similarly, GCD, the concept is important. Okay, you try to understand this. And remember, all these are functions. Okay, please do not get confused by these symbols. Okay, symbols are very confusing in mathematics specifically. Remember, sum is a function. It's a different story that a plus b can be also be written like this, right? Sum of ab. Similarly, 2 choose 3, or sorry, 3 choose 2. Okay, this one, this c, okay, actually is the function. It's a choose function where there are two attributes or two parameters, okay, like this, right?
Uncle, they use this in code, right?
Huh?
In
Yeah.
coding, they use it like this.
Which one in coding?
It will just be the
Yeah,
other.
Function.
Oh, it functions, correct, you're right. Yeah, okay. Similarly, when somebody is asking, right, a factorial, right, I'm telling n factorial, this is nothing but telling, okay, it's a function, okay, it's a factorial function, and factorial is called a recursive function. Why is called recursive? It's
It goes over and over, like
over
it.
and over. So you
yeah.
know, if you give it, okay, you tell that return, okay, in if you really code it, it will be return factorial, right, times n minus 1 times, not times, n times factorial n minus. So what is happening? It'll factorial 5. It comes here, it'll 5 times, but then it calls itself, right? So it goes back here. But with what? With 4, right? So it'll,
It
hey,
keeps going until you reach.
it goes until it reaches 1. So we'll add a condition while, okay, n is greater than 1, something like this, right?
you have to create like somewhere to stop, like a stop.
Yes, that's a stopping condition, stopping criteria. So essential thing that I'm telling you, this is recursive, right? But ultimately it's a function that's what I want you to understand. I mean, sometimes people tell, okay, fine, this exclamation sign, and when they see the plus sign or this sign, okay, they think, okay, these are all different things. But what they do not realize, okay, even that something like a choose, okay, is nothing but an action that you are doing, or something you are doing on a black box, okay? You are giving some inputs. Here the inputs are 2 inputs, and it comes back with some values, right? In this scenario, we know it is 3 factorial over 2 factorial over 1 factorial, right? So you are doing some action and brings back, okay? Similarly, GCD, when you're talking about, that also is a function. Ultimately, mathematics, everything that you'd be doing is a function. You later on learn in calculus something called DDX, okay, which you call differential function. But remember, this might be a fancy symbol, okay, because some mathematician, some intelligent people, wise man, came up with a symbol. But he could have given up no better symbol. He could have given no my name, Shutanu could have been the symbol. Okay, if no, nothing would have changed, but I was not there. Okay, so this is more of a symbol. Symbol is not the important point. Point is that what does the function do? We call it GCD. In our time, we also used to call it HCF. Ultimately, they're same thing. It's called highest common factor, greatest common divisor. These are same thing. Okay, after all. Okay, so in India, those people who are after India means I'm telling the entire Indian subcontinent. Okay, those who came from the British rule. Okay, our previous generation, our fathers. Okay, I learned GCD. Okay, I knew that, but they learned this HCF because British used to use HCF means highest common factor, and because they were prevalent. Okay, most of the people learned this as HCF. In fact, if you ask your parents, they might, if you ask them GCD, they might not be able to understand. Tell them, oh, it's not GCD, same as HCF. They would immediately understand because that is more relevant. But point is not, is it called HCF or GCD? My interest is that what is greatest common divisor? So let's break it, okay, and try to understand. If it's talking of divisors, okay, that means we need to know the factors, right? So let's take off two numbers, say 40 and 30. They're talking of the word D, right? Divisors. Who are the divisors of 40? So let's start doing it. Okay. 2, 20, 2, 10, okay, 2, 5. Okay. So we can tell 2 times 2 cube times 5. Do you agree? 2 cube is equal to 8. 8 times 5 is equal to 40. Do you agree this is true?
Yeah.
Okay.
Yeah.
What is 30? 30 is again 2, 15. And you're telling uncle is teaching us and all this, whatever we learned in the 4th grade or 5th grade. Okay, why are you learning it again? You will soon see why I'm telling all this.
Isn't this prime factorization, Uncle?
It's prime factorization. That's what we are essentially doing. So we are finding all the factors, right? Now they have asked us to find the common factors, right? See, GCD, if you break it, first we talked about divisors. So what are the divisors of 40? So divisor of 40 could be 2 is a divisor, right?
But there's also another 2. And
then could be 4 also is a divisor. 8 also is a divisor. See, let's do it again together.
There's 5.
Yeah, let me do it. So I talk about 40. So 2 cubed times 5. And also talk about 30. Right? 30 or something else. 30. 2 times 3 times, yeah. 2 times 3 times 5. Now, if I ask you to find out, see, let's break it, okay? Do not do it, jump it this time, not like in school, okay? I'll tell you, okay, what essentially in your brain you are doing. I'm not getting inside your brain, okay? So you are doing like this. You're telling 5 means, okay, 5 times 1, right? 2 times 1, 3 times 1, 5 times 1, right? There's no problem with that. So where you are starting is this. You are going for the 2, or telling, well, 2 to the power 0 could be a factor of 40. What is 2 to the power 0? 1, right? Is 1 a factor of 40? Is 1 a factor of 40?
Yeah.
Oh, yeah, Uncle.
2 to the power 1.
Yeah.
2 to the 2 squared.
Right. And then 2 cubed.
And
so there's
5
4.
to the power 0 is a factor of 40.
Oh, Uncle, is that why? That I was actually gonna ask you before you did this why they tell you to add 1 and then multiply all the numbers. They tell you to do the prime factorization and then add 1 to the.
Why add 1?
Yeah, I didn't know because of the 2 to the 0. Like that's also a possibility, right,
For
Uncle?
which question?
So if they were to ask you find the prime factorizations of like 2000, Uncle, or how many factors?
Because 1 is a factor, but that is not relevant. Whether that's not the reason why I'm even asking you. So I'll get to a little bit. No, just wait and watch. Okay, what I'm doing. Okay.
Yeah, sure, Uncle. That was just a realization,
Yeah.
Uncle.
Yeah. So do you agree up till this, all of them are factors? I know that these are not 2 to the power 0 and 5 to the power 0 are same thing. I understand that part. Okay. So far,
Yeah.
but is it everything?
Yeah.
No, answer is no. We have more factors. Okay. So let's see. Okay. So
Itself
far,
is a
You're missing 2 times 5, like all the.
so let's do it a little bit calibrated way. Calibrated way means I'll do methodically. Okay. So far I've drawn this. Okay. Now I'll do some cross. Cross means I'll marry. Okay. So 2 to the power 0 times 5 to the power 0. What is that?
1.
10 or 1, sorry.
1. 2 to the power 0 times 5 to the power 1. What is that?
5.
2 to the power 1 times 5 to the power 0. What is that?
2.
2.
2 to the power 1 times 5 to the power 1. What is that?
10.
Then 2 to the power 2 times 5 to the power 0. What is
4.
that? 4. 2 to the
20.
power 0 times 5 to the 1. 4
And
to
then 8. And then 4.
and then 2 cube times 5 to the power 0, which is 8.
And then
2 cube
40.
to the power 1, which is 40 itself. This 10. Can I tell all these are the factors of 40?
Yeah.
Now, if I tell you how many factors of 40 has, can you tell me, or can you define an algorithm to do it? Algorithm means you will tell, okay, fine, uncle, it doesn't matter, it's 40 or n, I know how to do it. If I ask you how many factors are there, without doing the counting like a kindergarten, okay, person, okay, I want you to do better. But before you ask that question, okay, we'll come back to this question. I want you to think about a fundamental question that I'm asking, okay? And because this will now help you to get into thick of thin in mathematics, okay? I will tell you ask you a very, very simple question. I know both of you can answer, but tell me, okay, how will you do it? I give, okay, 5 dots, okay? Not 5 dots, 1, 2, 3, 4, 5, 6, okay? 6 dots and a few cross. I tell that every dot and cross, okay? Few cross, okay? Every dot and cross are related, means every dot should be mapped to one cross. You understand? Every dot can be mapped to a cross. That means one dot can be paired with a one cross. So far, good with me?
Yeah.
Yeah.
Now I ask you, can you tell me that we have all the dots and the cross, okay, being exhausted after the mapping is complete, and they can be only be mapped with one cross. One dot can be mapped to only one cross. That's an easy thing, uncle. I will count the number of dots and then also count the number of cross. If they are equal, then we know that they can be mapped. If one of them is excess of the other, okay, then there is some excess, and therefore there is something that we left behind.
Yeah.
But here is the problem. Now that's the easy thing, right? But I will ask you a different problem. Problem is this: you are a kindergartner, or maybe not even a kindergartner. Before that, okay, you do not know how to count beyond 3. You can only count 3. You do not know what comes after 3. You are learning counting only. Now, how will you answer my previous question? You do not know what comes after 3. You have no way. And I've clearly given you more number of dots and cross, okay, which is much more than 3. And you have no idea what comes after 3. You do not know the representation of 4 or 5, or you do not have any idea. But you have been asked this question: is there no dots more than the cross? What will you do?
You break it up and count in 3s until you find.
Oh, you do not know that also, right? Because you are thinking bring it could be, right? There could be, here it is easy because you are seeing 3, but think of it, okay? Now you have even break up in 3, okay? You have more, no? You can, know how to count 3 groups, right? But now we have 4th group also, right?
Yeah.
Again, we are landing on the same problem because you do not know what comes after 3. You have no idea. That concept of what comes after 3 is not known to you. You are somebody who is maybe grade, you are 3 years old, okay? Who has been only be taught 1, 2, and 3. You do not know anything other than that.
Mm-hmm.
You do not even know what is 4. And you will understand why I'm talking about this example. And if it gets into your head, I'd be very happy. So if this is a problem, what we can do is that, because he's a kid and he does not know, okay, he'll tell, I'll not do like this, okay? Let's do some other way. You will start mapping like this. You remember when you were a kid, we used to draw lines, okay, between two dots and all this, and connect the dots, remember?
Yeah.
Let's connect one cross with one dot. What dot? He's doing it?
Yeah. You're just connecting it.
Connecting
Oh,
it.
until one
Until okay, one of them is
yeah.
exhausted. Now you
One.
can tell, right, whether it is exhausted or done, or he can have an answer. But he does not know. He's not really counting one by one, anything. He's
Just
only connecting. He's finding a relation between connect and dots. So far, good. So that
Yeah.
means a problem, okay, where something is greater than not, it's not necessarily I have to count the individual groups and then compare. I can do a little bit better. Okay?
No, they can't connect one of them. So like
Connect to one of them. Now this connection is called, also in mathematics, this is called mapping. Okay, they call map. You're mapping X to the circles, right? Map, or in common language, something called marry, right? Marriage. Okay, this mapping, marriage. Okay, this is a very, very powerful principle, and you learn, okay, why it is powerful. So let's go back to the question that I started. Okay, what is the question I asked? I asked you how many ways, or how many factors does 40 has? Of course, you can now count it one by one, right? But can you do better?
if you go back to the exponent parts, like each of the
You
five
can map the exponents, right? Like you just showed us.
yeah, you map the exponents basically.
Yeah, like you just showed us.
What is that?
And each like base 5 exponent would have like 4 connections, which would get you 8 in total.
Yeah.
Since there's 2.
Repeat it once again. Sorry, maybe I missed it.
So like you see that there's like 2 of the like 5 bases, like the ones with like a base of 5, the exponents, those ones will each have like 4 connections. So in total, you would then have 8. Fantastic. Since there's 2.
I think you're getting a sense, but let me test out whether really you've understood or not. Okay, I think both of you have understood it. Okay, based on what you're answering. Now I'll take a test. Okay, really you've understood it or not. So if there is a number, okay, n, okay, which can be represented by prime factorization as something like this. P1 is a prime number, okay, multiplied to the power of alpha 1. Alpha is a Greek letter like A, right?
Right.
And there's another one called P2 times alpha 2, and then P3 times alpha 3. Remember, P1, P2, and P3, all of them are prime number, because we have done prime factorization, right? Just like here, the 2 and 5 are prime numbers. Here, P1, P2, and P3 are prime numbers to the power exponent, okay? So you could do a prime factorization of n, and this is the way it looks like. Can you tell me how many factors does n has? Look at the previous example and come up with an answer.
Uncle, I'd be able to tell you, but that's because I know the formula, Uncle.
Again, because you are so much soaked in the formula that you're not able to come out. And I want you to come out of that, okay? To be a better mathematician.
So you're asking us like how many factors there are?
Does n have?
Does n have? And the ones you listed are just the prime factors.
Yes, P1. So I'm telling P1, P2, or P3 are the prime factors, right? So
yeah,
of course, it's prime factor to the power something, as you saw here, right? It is in 40 you had, okay, 2, 3, right? To the power 3, right? The exponent was 3, and another exponent was 1. So those are the alpha 1s, alpha 2s, and alpha 3s. P1, P2, and P3 are of course different prime numbers. Very difficult question, right?
Yeah.
Okay. See, we have to think a little bit more. What I'm saying is that no, you guys are not thinking, okay? Because if after answering this question, okay, then this question was a pretty easy thing. Let me help you, okay? And let's see whether you can understand it or not. What I'll do is, yeah. So can I tell n, the divisors of n are P1 to the power 0 is definitely a divisor?
Yeah.
P1 to the power 1 is also a divisor.
Yeah.
P1 to the squared is also a divisor to P1 alpha 1. All of them are divisors. Do you agree or not?
Wait,
Just
Yeah.
like
P1.
pick up it example in the here. You went till 3, right? Because it
Yeah.
was 3 here. So here you'll go till P1 to the power alpha 1, right? P to the power 0, P to the power 1, P squared, no, 2P to the power alpha 1. Do we agree?
Yeah.
Is it a forceful yes, or it really have understood?
Wait. Wait, what's the bottom one?
P1 to the power alpha 1, this entire thing. That's what you did. Remember? 2 cubed. You went till 2.
Oh, yeah. You're just factoring the one out, like.
Yes, because
Okay.
you're factoring.
Yeah.
Manu, are you with me?
Uncle, I didn't hear you, Uncle.
Okay. So look at it here. Okay. So I'm telling that P1 to the power 0, is it a factor of n?
Yeah.
To the power 0 is 1. Of course, it's a factor, okay? Is P1 to the power 1 also a factor of n? As long as 1 is less than alpha 1. I'm assuming that.
Yeah.
Then P1 to the power 2 is a factor of n, as long as 2 is less than alpha 1. Or alpha 1 is less than 2.
Yeah.
Is P1 to the power alpha 1 also a factor of n?
Yes, because that's the whole thing.
Yes. So can I tell how many factors do you have only with P1, no P1 base? How many factors are you seeing?
Alpha 1.
Alpha 1 or alpha 1 plus 1?
Oh, alpha 1 plus 1 because.
Plus 1 because of 0.
Okay.
Yeah.
How many factors do you have for this? P to the power 0, is it a factor of n?
Yes.
Is P2 to the power 1 also a factor of n?
Yes.
Oh, you can repeat the same process, right? Until
So how many factors are there?
Alpha 2 plus 1.
Plus 1. Very good.
Yeah.
Next one.
Then alpha 3 plus 1.
Same thing.
What are the total number of factors then?
Do you multiply them?
Alpha 1 plus, whoops.
Alpha 1 plus 1 times alpha
You
2
just
plus
multiply
1
them.
plus times alpha 3 plus 1. Ultimately, it does not depend on the base itself at all, right? You're all that you did was that you got the exponent, okay? You might add 1 to them, okay? And you multiply. So this is my algorithm. How good is this?
That's amazing.
You never counted it actually.
Yeah.
Now, you might not see the benefit in a small one, but if I give you a big one, then you see the benefit. For example, if I give you a number, like say, maybe, say, yeah, this one could be a good one. Say 9,000. How many factors does 9,000 have? Both of you can do use a notebook, use this principle, and think about it, why you are doing, okay, and come up with an answer and tell me how you arrived at the answer. Find the number of factors, okay, distinct factors of 9,000.
$48.
48?
Yeah.
Okay. Srinita, do you have an answer?
I'm not getting there.
Okay. I'll give you another few seconds and then we can dig into it.
Yeah, I got 48.
How did you get 48, one of you?
Because so basically the first
You do
round
the
is
prime
the prime
factorization
factors.
first.
Prime
So I got
factors. Okay.
3 to the second and like 2 to the third and 5 to the third. And then each of those would have 3 to the 2nd would have in total 3 factors. And then 2 to the third would
4 factors.
have 4, and then same would happen for 5 to the third.
So 2 plus
and then
1.
you get
Correct.
Yeah.
I got it. So you did this one, right? You watch
Yeah.
this. You're not interested in whatever is coming here. This is not your interest, okay? You're interested.
no.
But again, a lot of places you will see that they will give you a formula in some cases, especially as you prepare for SAT and other things, you'll be doing it, okay? See, in these books, you will see that they will give you the formula. They will not tell you where they got it, okay? I want you to not remember formula, okay?
Yeah.
That kills banana, because then the question is twisted. You also struggle, okay? But if you understand that, then any question thrown at you, you understand, oh, I know why it is happening. It's very simple, right? You have to do a little bit of practice and understand why you are doing. Just do not remember the algorithm itself. Try, where did the algorithm come from? How did you find it? It's not too difficult. Do you think it's too difficult for you? No, right?
Once you get it and like why, it's fine.
Yes. True, Manu? Do you agree?
Yeah, I agree. That's how I did it.
Good. So now let's go back to our GCD problem where we started, right? GCD of A and B. So if we have the divisors, okay, so let's say 20 has 2, 4, right? 5, right? And 20. And say another one has maybe 25. 25 has 5. Of course, 1 is also there. I can write it. And 25, right? If I tell you, okay, these are the divisors you have. Now, what are the common divisors you have? 1 is a common divisor because 1 is there in both cases. 5 is also a common divisor because it's there in both cases. And who is the greatest among them? Of course, 5, right? So
Yeah.
5 is the GCD of 20 and 25, right? This is what has been taught in school, okay? And this is good with me, okay? Now, I ask you a question. Give me a second, yeah. Okay.
Well,
okay, let me explain to you what I've done. 1, 2, 3, 4, 5, 6, 8, 10, 10, 1, 2, 3, 4, 5, 5. So we have a 10 by 5 grid, okay? It's 10 by 5, yes. 5 by 10. 5 by 10 grid, right? 5 rows and 10 columns. And then I do a diagonal from the left bottom corner to the top right corner. Okay, you see the diagonal that I've drawn. I'm asking you, okay, how many cells means each of them is one cell, okay? You understand? How many cells have this line crossed in this journey? So for example, you see that this is the first cell, right? This is the first cell, it has crossed. This second cell, right? It is crossed. And then I do not know whether it's really going to the corner or not. That's something I will let you think, okay? I will not tell that, okay? But you see that this is third cell, it has crossed. Fourth cell, it has crossed. Fifth, it has crossed. Sixth, it has crossed, okay? Seventh, it has crossed. And 8, and then 9, and then 10. So answer looks like 10 in this scenario. Looks like that, okay? Maybe I'm wrong.
Yeah.
I want you to tell me how many cells it has crossed. And if that question is difficult, okay, you can also tell me how many lattice points it has crossed. So lattice points are like this. These points, all these points, right, where there's the intersection between a row and grid, okay, grid column and grid row, okay, these are all lattice points. You understand? So 5 times 10, 50 lattice points are there, right here. How many lattice points is it crossing? Okay, lattice points means this is not a lattice point, remember. This one, the one that I'm highlighting, or this one is not a lattice point because it's passing through our row, right? It's not passing through a lattice point, but some cases it passes through the lattice points. So I want you to tell me how many lattice points do they cross and how many cells or grid, okay, grid cells they have crossed. If from when they move from one left bottom corner to the right corner, okay, if we go in a straight line along the diagonal, how many lattice points, how many grid cells? I'll give you exactly 1 minute. Your time starts now. Think of the algorithm. I need not have an answer. Okay, I want you to think.
$27.
So is the answer for what, Manu? Sorry.
27 lattice points.
27 lattice point. That's way too many. No way to be 27. Because think of lattice points, as I told you, right? Think of it. If the grid is this, okay, and maybe I'm small, you're not able to see it. Let me make it a little bit bigger so that you can see it. Okay. So think of it. I have a magnified up view, okay, so that you can see it out here. Right? Look at this. If I start from here and it passes through the lattice points, what are the lattice points is passing?
It only goes through one. I actually started at the
That's
same.
correct. This is not a lattice point.
Oh wait, what? Which one's
Man,
that?
this is a lattice point, but it does not pass through the lattice point, right? Remember, this is not a lattice point. Whatever I'm crossing, these are not lattice points. This is not a lattice point. This is not a lattice point. Only this is lattice point. So here, the answer is 2, right?
Fine.
It's close to the lattice point, but not really passing through the lattice point.
Does it cross 2?
2 of them, because
For which one? 5 by 10?
2, yeah.
2 by 4.
Huh?
Yeah. 2 by 4. It passed 2 of the lattice points.
It passes through two lattice points. Okay. Do you have a graph paper with you?
Yeah.
Can you go a little bit slow? I know we are almost closing in. We have 2 minutes or 4 minutes. I want to finish this. Can you quickly do it, draw it for me and see whether it's really not 2 or a little bit more? I'm telling it's not 2. It's more than that.
Wait, so lattice points are if what's the criteria for lattice points?
Lattice points means when the grid cell and the row cell they are meeting, right? As I told you, this is the lattice point, right? All these are lattice points. Remember, these are all lattice points. So I'm telling you, as we go from the top bottom left to the top right, how many lattice points do they pass through that line? You told it is 2, as if no bottom and the top are the only one. I'm telling no, it's not 2. But what is it?
I thought it was like slope.
Slope. Okay.
It's a straight line, right, Uncle?
Can you tell me when would they go through the lattice point? Is there a pattern to it?
It would go after like a 2 by 4.
2 by 4 or 2 by 1? Or 1 by 2, sorry. 2 by 1, my bad. 2 by 1. Sorry, 1 by 2.
Yeah, sorry, yeah.
1 by 2, 1 by 2. Every 1 by 2 will have it pass through. Think of it. And why is true? Okay. If these are the 2 cases, right? It has to pass through this. So for example, here and here, it is passing through the lattice point. Again,
that's also like slope, right?
Huh?
That's also like slope, right?
That depends on slope or not. It always would not be the slope. So I can give you another example. So what will happen in case of 10 and 6? It's 5, right? 10 and 6, it would be something else. I am telling, and I'm making a hypothesis because this is something I want you to work on, okay? I'm telling you the number of lattice points should always be greatest common divisor of m and n, if it's m by n row, right? M and n, m is the number of rows, n number of columns, or other way around, okay? Plus 1. I'm telling you this is always true. Can you tell me why? I'm giving you a hypothesis.
Is this generally true, or do you want us to tell it like you want?
I'm telling this is always true. The number
Okay.
of lattice points it passes through is greatest common divisor of m and n plus 1. It's very simple to think, but I want you to think very clearly, okay? If I find the greatest common divisor of m and n, okay, then you know, okay, how soon it would be repeating, okay? Think of it. How soon it would be repeating. So think of it, why the greatest common divisor of m and n would play a role in this scheme of thing.
I think it's because there's like a pattern of when it crosses. So each time you go.
I want both of you to think, okay? It's 2:59. I could have given you the answer right away, but I want you guys to think before, and maybe I'll put that as a question and as an assignment, okay? I want to think and come instead of me revealing you the answer. I'm telling you GCD of m or n plus 1. And that will help you also to find out how many grid cells it is going, okay? I'm telling you number of points, okay? Number of cells it will go is same as m plus n minus GCD of m and n. M plus n minus GCD of m and n. That's the number of cells it will cross. Cells means grid cells. So we're talking two things, right? How many lattice points it would cross? It is GCD of mn plus 1. And number of cells it will cross is m plus n minus GCD of m and n. Try it with small examples. Play with the grid, draw a number of times and see whether you're seeing some pattern. Okay, is the pattern repeating? For example, every 2 cells, as Srinita was telling, right? It's repeating? Okay, what is happening when it's crossing? Okay, ask yourself question, do it small samples, okay, and see, are you able to see a pattern instead of me revealing you the answer? I want you to take it as a puzzle, okay, and try to see whether you can find an algorithm. I already told you the algorithm, but I did not tell you why I got this algorithm. That's something I'll reveal, okay, after you give a little bit of try, instead of me telling you everything, okay, in the first go itself. That will just that is not the right way of approaching mathematics. That's how I would tell. Okay, you better go step by step and think about it. Okay, is something you can do for me? I'll put that as an assignment. Don't worry about it. I'll put it in Canvas so that you can do it. But the idea is that I want you to find answer to 2 things: how many grids lattice point will cross? Is there a pattern? And is it really matching with whatever I'm drawing? Okay, and or whatever I jotted down. And how many grid cells is m plus n? M is the number of cells and followed a number of columns, or the other way around. Does really matter, because m and n has a symmetric relationship. Symmetry, because it doesn't matter if you exchange m with n, it will still be the same answer, right? So m plus n minus GCD of m plus mn. Okay, why is it true? Can you try it for me? Maybe one day I will give you, and then by tomorrow we can.
Uncle, I don't have graph paper, but when I
You have to get a graph paper. You cannot be a serious mathematician without a graph paper. Okay, means this is something I keep on telling to all students. Graph paper is a must for any mathematician. Means, in fact, I do not allow my students to do it on a white paper or any paper. I'm a little bit stringent on that way. You know, those who have walked with me, they know that, okay, if I look, I want a graph paper. You should do mathematics only on graph paper. Okay, so get a graph paper. Okay, or if you right now, if you do not have it, you can draw it for you, just for the sake of this example, just like the way I was doing it. Okay, quickly. But graph paper is critical, because that will help you not only now when you do geometry and as you move, okay, in AMC and other competitive examination. Graph paper makes a lot of difference. Okay, it helps you think in a different way. Got it, Manu? Good. Are you good at this?
Yeah, Uncle.
Okay. So give a try, and then of course I'm there. Okay, I'll ping me whatever you find out. I see, the point is that, as I told you, mathematics is not about, okay, me giving you some formula. I can do that easily, okay, but that's
Oh, when do you want
way
me to
traffic.
tell you this by, uncle?
By
When
tomorrow.
do you want me to tell you what
By
I
tomorrow.
found?
You have a holiday tomorrow, right?
Yeah.
So I think it's one evening is enough. Okay, so start thinking right now. Moment you have an answer, okay, ping me in WhatsApp, or no, put a discussion forum in the send me in the inbox, right, in our campus. Tell her this is how I come up with this answer. But test your answer. If you have some formula, something, okay, you find out, see that whether it's really working or not. Okay, with some samples, right? With m and n being changing the values of m and n, find out whether it's really matching, and then tell why is it matching. Okay, come up with some logic. That is real mathematics. Mathematics is not about me giving you a formula and telling, hey, Srinita or Manu, okay, if you see this problem, this is the solution. By you have to remember this formula. That's the ugly way of presenting mathematics. Okay, and I will definitely help you, but I want you to think. Okay, these two questions you think, and this will help you a lot. I'll tell you a lot of good things are coming, but I want you to think about it. Okay. That's it for the time being. Okay, have a good day ahead, and then let's keep on discussing things in Canvas, and then of course we'll meet next week. Okay, and take it from there. We'll be meeting one day in the weekend or day also, right? Wednesday we are meeting every week, Wednesday. Okay, but there could be some other kids also joining. Okay, but
Wait, so what are the meeting dates?
Wednesday and Saturday, Sunday we'll be meeting at 12:30, 1 o'clock. Okay.
Online.
And that we'd like to meet, okay, in person on Sundays, if possible. Okay, that's what we're doing and continue to do. And Wednesday we'd be meeting online. When we start the physics class, okay, it most probably would happen on Saturday. Okay, if that's how I try to plan. So there also we'd need just like this. Okay, we'd meet one day in person, and another one day we'll dedicate only for online. Mainly online, I would not talk much. Okay, online the way it would go is that you would be asking the question, okay, and I would be answering. In person, when you'd be meeting, I'd be talking more and I'll ask you questions, okay? But the other thing is you should be asking me a question, not me. That's the whole idea. That, uncle, this is the question, okay? Whatever question I give you in Canvas, this is where I got stuck, okay, can you help me? And that's where I would be pitching in. And that is, again, not mandatory because I would not be teaching anything on that Wednesday, okay? So if you do not have anything, you think it's not needed, it's fine. You can drop. Okay, so we'll have it in this way. Okay, one day dedicated to learning, other part dedicated to problem solving or wherever you're getting stuck. Okay.
So Wednesdays, what time?
Wednesday 7:30. Sorry, I should have told. 7.
Yeah. Okay.
Yes, and days like this when we could not meet, we'll have it over Zoom, but this would not be the manner kind of norm. We'd like to meet more in person, okay, on Sundays rather than on Zoom. Okay, but please do problem solving. I'm telling you, there is no second way of learning mathematics other than problem solving. We can keep on talking for hours. Ultimately, how many problems you solve would matter, but again, doing blank problem solving without even having the foundation thing, whatever we are now learning, these are, I consider them as ABC. I'd be very honest with you. These are ABCDs. If you do not know ABCDs, you cannot write a big essay, right? Or a big composition, right? You not understand what it is. So you have to know the ABCDs. Then you can only do problem solving. Otherwise, you'd struggle like anything. Okay? So think about the problem. Let it take 1 hour. That's fine. Let it take 2 hours just to get it. Good with me. There is nobody telling that you're boxed by time. You have to do it in 5 minutes. Okay? But try to think. That's all I'm requesting both of you. Okay. Take care, Manu and Srinita. We'll keep on talking.
Yeah. Okay.
Bye. Thank you.
Yeah. Thank you.